September 3, 1939, the Manufacture d'Armes de Saint-Étienne, known simply as MAS, received urgent orders from the French War Ministry. War with Germany was now inevitable, declared just hours earlier, and France's military faced a sobering reality. While the German Wehrmacht had been rearming aggressively for years, France's arsenal remained largely unchanged from the Great War. Among the most glaring deficiencies was the near-total absence of submachine guns, automatic weapons that had proven their worth in the trenches of 1918 but had been largely ignored in the 2 decades since. The French army, still wedded to doctrines emphasizing rifle marksmanship and the bayonet charge, had only recently acknowledged that modern warfare might require more than bolt-action rifles and light machine guns. The MAS-38, a peculiar little weapon chambered in an underpowered cartridge, represented France's belated attempt to field a submachine gun, but by the time production ramped up in early 1940 it was already too late. This is the story of that weapon, the alternatives France considered, the battles it barely fought, and how French submachine gun development reflected the larger tragedy of a nation unprepared for the war it was about to lose. The MAS-38's origins traced back to the early 1930s, when French military observers began reconsidering the submachine gun's role. During the First World War, Germany had introduced the MP-18, the world's first practical submachine gun, in the final year of fighting. This weapon, firing the 9mm parabellum cartridge from a 32-round magazine, had proven devastatingly effective in trench raids and close-quarters combat. The Allies, including France, had taken note but drew different conclusions. The British largely dismissed submachine guns as specialty weapons of limited utility. The Americans, having barely gotten into the war, focused on other priorities. The French, however, recognized the potential, but approached the problem in a characteristically French way. They would design their own cartridge, their own weapon, built to French specifications and French manufacturing standards. The cartridge they developed was the 7.65 mm long, a round that would prove to be both the MAS-38's most distinctive feature and its greatest handicap. French ordnance designers reasoned that standard pistol cartridges like the 9mm parabellum or 45 ACP generated excessive recoil in lightweight automatic weapons. They wanted something more controllable, easier to manufacture, and better suited to the slight builds of colonial troops who might use these weapons. The 7.65 mm long emerged from these requirements. It fired a 55-grain bullet at approximately 150 feet per second, generating about 162 foot-pounds of energy at the muzzle. To put this in perspective, the 9mm parabellum, the standard submachine gun cartridge used by most nations, generated roughly 350 foot-pounds of energy. The 45 ACP used in the American Thompson submachine gun produced about 370 foot-pounds. The French cartridge generated less than half the energy of its competitors. French designers defended this choice with logic that made sense in peacetime, but would prove disastrous in combat. Lower recoil meant better controllability, they argued. The lighter cartridge allowed soldiers to carry more ammunition. The reduced power meant less wear on weapon components, extending service life. Wounds from the 7.65mm projectile, while not immediately incapacitating, would still put enemy soldiers out of action. These arguments convinced the French military establishment, which approved the cartridge in 1935 and ordered MAS to develop a submachine gun around it. What they failed to consider was that in actual combat, soldiers needed stopping power more than they needed controllability. A wounded enemy soldier could still shoot back. An enemy soldier hit with a 9mm or 45 caliber round was far more likely to go down immediately. The weapon that emerged to fire this cartridge was equally unconventional. The MAS-38 looked like no other submachine gun of its era. Most submachine guns followed a simple blowback design with the barrel and magazine in line with the stock, creating a straight utilitarian appearance. The MAS-38 was different. Its barrel was offset below the line of the stock, angled slightly forward, giving the weapon a distinctly hunched appearance. The magazine well protruded forward at an acute angle rather than mounting vertically. The bolt travelled forward at a downward angle to chamber rounds. The entire design looked awkward, almost experimental, as if the engineers at Saint-Étienne had deliberately chosen to ignore every convention of submachine gun design. There were reasons for these oddities. The offset barrel reduced muzzle climb during automatic fire, keeping the weapon more stable. The forward-angled magazine made it easier to change magazines while prone, a consideration for trench warfare. The compact dimensions, just 26 inches with the stock extended and 19 inches with it folded, made it easier to maneuver in vehicles and confined spaces. The weapon weighed only 6.3 pounds empty, lighter than most competing designs. On paper, the MAS-38 represented innovative thinking, solving problems through unconventional engineering. In practice, it created new problems while solving old ones. The manufacturing process for the MAS-38 was complex and time-consuming, reflecting French emphasis on precision and quality over speed of production. The receiver was machined from a solid block of steel rather than stamped from sheet metal. The bolt was precisely machined with multiple locking surfaces. The barrel required extensive machining and finishing. Each weapon took approximately 22 hours of machine time to produce, not counting assembly and testing. By comparison, the British Sten gun, developed in 1941, could be produced in less than 5 hours of machine time. The German MP40 required about 12 hours. The Soviet PPSH-41 could be stamped out in about 7 hours. The MAS-38's production time meant that even with the full capacity of the Saint-Étienne arsenal dedicated to it, France could only produce about 200 weapons per week. Production officially began in 1939, but the bureaucratic machinery of French military procurement moved with characteristic slowness. By September 1939, when war was declared, MAS had delivered fewer than 700 weapons. By December 1939, production had increased to about 50 weapons per week, yielding perhaps another 600 guns. By March 1940, with German invasion increasingly imminent, production finally ramped up to maximum capacity. But maximum capacity at Saint-Étienne meant only 200 weapons per week. When German forces crashed through the Ardennes on May 10, 1940, the French army possessed fewer than 2,000 MAS-38 submachine guns for an army of over 900,000 men. Those 2,000 weapons were not distributed to frontline infantry units. French military doctrine in 1940 remained firmly rooted in the experiences of 1914 to 1918. The infantry's primary weapon was the MAS-36 bolt-action rifle, a modern and well-designed weapon that fired the 7.5 Yasafty 54mm cartridge. Each infantry section included a Fusil mitrailleur model 1924-29, an excellent automatic rifle that provided fire support. Submachine guns, in French thinking, were specialty weapons for specific roles, not general issue items. The MAS-38s that had been produced went primarily to the Garde Mobile, a national gendarmerie force tasked with rear area security, and to military police units. Some went to tank crews and vehicle drivers as personal defense weapons. A few went to specialized reconnaissance units. Almost none went to the infantry divisions that would face the German onslaught. This distribution reflected a fundamental misunderstanding of how modern warfare had evolved. The Germans, by contrast, had integrated submachine guns throughout their infantry structure. Each German infantry squad in 1940 included at least one soldier armed with an MP-38 or MP-40 submachine gun. Assault engineers and motorcycle troops carried them extensively. Paratroopers relied on them heavily. The German military understood that modern mobile warfare created numerous close-quarter situations where rapid fire was more valuable than accurate long-range shooting. The French, preparing to fight the last war, had organized their army to hold defensive positions and conduct methodical set-piece attacks. Submachine guns had no place in this doctrine. The Battle of France, which began on May 10, 1940, exposed the fatal flaws in French military thinking within days. German forces employing Blitzkrieg tactics, combined arms coordination between tanks, infantry and aircraft, tore through French defensive lines with shocking speed. Within a week, German armoured columns had penetrated deep into France. The methodical, doctrine-bound French army, organised for static defence and slow-moving attacks, proved incapable of responding to the speed and violence of German operations. Individual French units fought bravely, often to the last man, but tactical courage could not overcome strategic obsolescence. In this chaos, the handful of MAS-38 submachine guns in French service saw limited action. Most remained in the hands of rear-echelon units that never engaged the enemy. The Garde Mobile units equipped with them found themselves overrun by German armour before they could effectively resist. A few instances of combat use were documented, though detailed accounts are scarce. One report from late May 1940 described a Guard Mobile unit near Abbeville engaging German motorcycle reconnaissance troops at close range. The French gendarmes, armed with MS-38s, ambushed a German column moving through a village, firing from buildings at ranges under 50 metres. The engagement lasted less than 5 minutes before German infantry arrived with armoured support, forcing the French to withdraw. The after-action report noted that the MAS-38s had performed adequately at close range, but that the underpowered cartridge required multiple hits to reliably stop targets. Several German soldiers had continued fighting after being hit, something that would have been far less likely with 9mm parabellum rounds. Another account, less well documented, described a French army reconnaissance unit near Sedan, equipped with MAS-38s engaging German paratroopers. The French soldiers, attempting to probe German positions in a wooded area, encountered a squad of Fallschirmjäger armed with MP-38 submachine guns. The firefight that ensued revealed the stark difference between the weapons. The German MP-38, firing standard 9mm ammunition, consistently dropped targets with short bursts. The French MAS-38, firing its weaker cartridge, required longer bursts and more ammunition expenditure to achieve the same results. The engagement ended when German reinforcements arrived with machine gun support. The French withdrew, having inflicted casualties but failed in their reconnaissance mission. These fragmentary accounts represent nearly the entire combat record of the MAS-38 during the Battle of France. By June 22, 1940, when France signed the armistice with Germany, most MS-38s had never been fired in anger. The Saint-Étienne arsenal fell into German hands largely intact, along with stockpiles of completed weapons, partially completed receivers, and manufacturing equipment. The Germans, always pragmatic about captured weapons, evaluated the MAS-38 and designated it the MP-722F, the F standing for Französisch, French. They issued captured examples to occupation troops, military police units, and security forces in occupied territories. German assessments of the weapon were mixed. Reports praised its compact size and controllability, but noted the weak cartridge as a significant limitation. One German evaluation concluded that the MAS-38 was suitable for guard duty and close-quarters work but inadequate for serious combat. The French experience with the MAS-38 stood in stark contrast to developments elsewhere in Europe. While France had spent the 1930s developing a submachine gun around an underpowered cartridge, other nations had been moving in different directions. Understanding these alternatives provides context for just how far behind France had fallen in small arms development. The Germans had revolutionized submachine gun design with the MP-38 and its successor, the MP-40. These weapons, developed in the late 1930s, represented a dramatic departure from earlier submachine guns. Instead of expensive machined components, German engineers had pioneered the use of stamped steel parts, welded construction, and simplified manufacturing processes. The MP-38, introduced in 1938, featured a folding stock, making it compact enough for vehicle crews and paratroopers. Its 32-round magazine, loaded with standard 9mm parabellum ammunition, provided excellent firepower. The cyclic rate of fire, around 500 rounds per minute, was deliberately moderate, making the weapon controllable and reducing ammunition consumption. Most importantly, German doctrine integrated these weapons throughout the military structure. By 1940, Germany had produced over 250,000 MP-38s and MP-40s compared to France's 2,000 MAS-38s. The German submachine guns had proven themselves in Poland, where they had been particularly effective in urban combat. German assault troops armed with MP-38s had cleared Polish positions in Warsaw with devastating efficiency. The weapon's combination of firepower, portability, and reliability made it ideal for the mobile warfare that defined German tactical doctrine. In France, these same weapons would prove equally effective. German motorcycle troops used them to rapidly secure key positions. Paratroopers relied on them during airborne operations. Infantry used them for close assault and clearing operations. The psychological impact was significant as well. The distinctive sound of an MP-40 firing, a rapid staccato burst, became associated with German military prowess and struck fear into defenders. The Soviets had taken a different approach to submachine gun development, one that reflected their vast population and industrial capacity. The PPD-40, developed by Vasily Degtyaryov, fired the standard 7.6 Tunku-25mm Tokarev pistol cartridge from a 71-round drum magazine. This high-velocity cartridge, pushing a bullet at over 1/400 feet per second, offered better penetration than the 9mm Parabellum and certainly far exceeded the French 7.65mm long. The PPD-40's large magazine capacity reflected Soviet tactical doctrine, which emphasized volume of fire over precision. Soviet infantry tactics called for rapid assault supported by overwhelming automatic fire. The PPD-40 fit this doctrine perfectly, but the Soviets would soon take submachine gun development even further. When Germany invaded the Soviet Union in June 1941, Soviet forces found themselves desperately short of weapons. The PPD-40, while effective, was too complex and time-consuming to produce in the quantities needed. Soviet designer Georgy Shpagin developed a radically simplified submachine gun that could be produced by unskilled workers using basic tools. The PPSH-41, introduced in late 1941, became one of the most produced weapons in history. Over 5 million were manufactured during the war. The weapon used stamped steel components, simple welds, and minimal machining. It fired the same 7.62 25mm cartridge as the PPD-40, but was far easier and faster to produce. Soviet factories stamped out PPSH-41s by the thousands, arming entire infantry units with them. By 1943, Soviet infantry squads were equipped with multiple submachine guns, providing a volume of automatic fire that often overwhelmed German defenders. The British had initially been skeptical of submachine guns, viewing them as inaccurate spray guns of limited military value. The British Army entered the war with virtually no submachine guns in inventory. This changed rapidly after Dunkirk, when Britain faced the possibility of German invasion with a depleted and under-equipped army. In desperation, Britain purchased Thompson submachine guns from the United States, receiving over 100,000 of these expensive, heavy but highly effective weapons. But the Thompson, costing approximately $200 per unit and requiring extensive machining, could not be produced in the quantities Britain needed. The solution came in 1941 with the Sten gun, one of the crudest yet most effective weapons of the war. Designed by Major Reginald Shepherd and Harold Turpin at the Royal Small Arms Factory in Enfield, the Sten was deliberately designed to be as simple and cheap as possible. It consisted of a steel tube receiver, a simple bolt, a crude barrel, and a skeletal metal stock. The weapon could be produced for less than $10 in materials and required minimal skilled labour. It was ugly, uncomfortable to shoot, and prone to jamming if not properly maintained. It was also exactly what Britain needed. Sten production reached 47,000 weapons per month by 1942. Over 4 million were produced during the war. The Sten armed British and Commonwealth forces, resistance fighters throughout occupied Europe, and anyone else who needed an automatic weapon quickly and cheaply. The American approach to submachine guns reflected American industrial and tactical preferences. The Thompson submachine gun, designed by John Thompson in 1918, had been developed too late to see significant use in World War I. During the interwar years, it gained fame as a gangster weapon, used by both criminals and law enforcement during Prohibition. When war came, the US military adopted it in large numbers, attracted by its reliability, stopping power and prestige. The Thompson fired the 45 ACP cartridge from either 20-round stick magazines or 50-round drums. Its substantial weight, over 10 pounds loaded, made it stable and controllable. The powerful 45 caliber round ensured excellent stopping power at close range. American infantry, paratroopers and Marines relied heavily on Thompsons throughout the war. However, the Thompson shared the same problem as the early British submachine guns. It was expensive and slow to produce. Each Thompson required extensive machining and skilled labour. At $200 per unit, it cost as much as several rifles. The US military needed something faster to produce. In 1942, designer George Hyde developed the M3 submachine gun, nicknamed the Grease Gun, for its resemblance to a mechanic's grease gun. Like the Sten, the M3 used stamped steel construction and welded components. Unlike the Sten, it was reasonably well designed and reliable. It fired the same 45 ACP cartridge as the Thompson, but cost only $20 to produce and could be manufactured in a fraction of the time. The M3 equipped American tank crews, vehicle drivers and infantry units, supplementing the Thompson throughout the war. Each of these weapons represented different approaches to the same basic problem: how to provide infantry with automatic firepower for close-quarters combat. The Germans prioritized controllability and reliability with the MP-40. The Soviets prioritized production speed and overwhelming volume of fire with the PPSH-41. The British prioritized ultra-cheap, ultra-simple production with the Sten. The Americans prioritized stopping power with the Thompson, and then simplified with the M3. All of these approaches worked, each in their own way, because they were produced in sufficient numbers, integrated into military doctrine, and chambered for cartridges with adequate stopping power. The French MAS-38 failed on all three counts. It was produced in utterly inadequate numbers. It was not integrated into French military doctrine. Most critically, it was chambered for a cartridge that lacked the power necessary for effective combat use. The 7.6 Arme Verstärktes 20 mm long, which French designers had thought would be adequate, proved in the limited combat it saw to be substantially inferior to every other submachine gun cartridge in use. German, Soviet, British and American submachine gun rounds all generated roughly twice the energy of the French cartridge. This translated directly into greater wounding potential, better penetration, and more reliable stopping power. After the fall of France, the MAS-38 story might have ended. The Germans captured the production facilities and most of the existing weapons. France was divided into occupied and Vichy-controlled zones. The French military was largely demobilized. But weapons have a way of persisting, and the MAS-38 would have a second, albeit limited, life in the hands of the French resistance. The French resistance, the various underground organizations that opposed German occupation, faced a desperate shortage of weapons. Arms caches hidden after the 1940 defeat were limited. Allied airdrops of weapons wouldn't begin in earnest until 1943. Resistance fighters made do with whatever they could acquire through theft, raid, or manufacture. A few MAS-38s had been hidden from the Germans in 1940, squirreled away by soldiers who refused to surrender them. Others were stolen from German stockpiles or taken from occupation troops in ambushes. The resistance also acquired a variety of other submachine guns through various means. British SOE, the Special Operations Executive tasked with supporting resistance movements throughout occupied Europe, began supplying weapons to French resistance groups by air starting in 1941. The most common weapon delivered was the Sten gun. Thousands of Stens reached French resistance fighters between 1942 and 1944. The weapon's simple design made it ideal for resistance use. It could be disassembled quickly for hiding. Its crude construction meant repairs could be improvised with basic tools. Most importantly, it used 9mm Kinea parabellum ammunition, which could be scavenged from German weapons or stockpiles. The Sten became the iconic weapon of the French resistance, appearing in countless photographs of liberation in 1944. But the Sten's crude nature also made it problematic. The side-mounted magazine, while distinctive, was prone to causing feed malfunctions if bumped. The simple bolt and spring mechanism could jam if dirt entered the receiver. The weapon had a reputation for accidental discharge if dropped or roughly handled. Resistance fighters using Steens learned to treat them with care and to carry cleaning supplies and spare parts. British instructors, parachuted into France to train resistance units, spent considerable time teaching proper Sten maintenance and safe handling procedures. American supply efforts added another weapon to the resistance arsenal starting in 1943. The OSS, America's wartime intelligence service, arranged for airdrops of supplies to resistance groups. These drops often included M1 carbines, compact semi-automatic rifles that could be effectively used at close to medium range, and occasionally Thompson submachine guns. The Thompson was highly prized by resistance fighters who managed to acquire one. Its reputation as a powerful weapon, reinforced by Hollywood movies and American prestige, made it a status symbol as well as an effective firearm. The .45 caliber round's stopping power was greatly appreciated by men who might face German reprisals if captured and needed to ensure quick kills in ambush situations. The Soviets, coordinating with communist resistance groups in France, supplied a small number of PPSH-41 submachine guns. These weapons arrived through complex smuggling routes and were relatively rare in France, but their appearance demonstrated the international nature of resistance supply lines. The PPSH-41's high rate of fire and large magazine capacity made it devastating in ambushes. though the unusual Soviet ammunition complicated logistics for French fighters more accustomed to German and British calibers. Italian submachine guns also found their way into resistance hands after Italy's armistice with the Allies in September 1943. Italian occupation troops in southern France, suddenly finding themselves on the Allied side, either surrendered weapons to resistance groups or had them taken by force. The Beretta Model 38, Italy's standard submachine gun, was one of the finest weapons of its type produced during the war. Beautifully machined, reliable, and firing 9mm parabellum ammunition, it was superior in quality to most other submachine guns, including the German MP-40. Resistance fighters, lucky enough to acquire a Beretta Model 38, possessed a weapon as good as any in Europe. German weapons captured in ambushes or raids provided another source of submachine guns. MP-40s taken from killed or captured German soldiers became immediate additions to resistance arsenals. These weapons had the advantage of using the same ammunition as Steens and captured German stockpiles. Resistance fighters using MP-40s could blend in more easily if circumstances required posing as German troops or collaborationist militia. The MP-40's reputation and reliability made it a highly sought-after weapon, though possessing one carried serious risk. German forces took the loss of weapons seriously and conducted brutal reprisals against communities suspected of harbouring resistance fighters who had killed German soldiers and taken their arms. In this diverse arsenal of British, American, Soviet, Italian, and captured German submachine guns, the MAS-38 played only a minor role. The few that had been hidden in 1940 eventually found their way to resistance groups, but they were never common. Resistance fighters who used them faced the same problem French soldiers had encountered in 1940, the underpowered 7.6 fuss downed 20th long cartridge. Ammunition was also a serious problem. The unique cartridge meant that MAS-38s could not share ammunition with any other weapon. Fighters armed with Stens could use ammunition from captured MP-40s or German stockpiles. Those with Thompsons could use .45 ACP rounds from captured M1911 pistols or American supply drops. The MAS-38 user could only use 7.6s of 20 long, a cartridge that had never been widely produced and was nearly impossible to acquire during the occupation. Some resistance groups attempted to manufacture ammunition for MAS-38s and other weapons using clandestine workshops. These efforts met with limited success. Producing ammunition required specialized equipment, raw materials, and expertise, all difficult to acquire and maintain under German occupation. The quality of home-manufactured ammunition varied wildly. Some batches were serviceable, others caused jams or weapon damage, a few catastrophically failed, injuring the shooters. Professional ammunition production required industrial infrastructure that the resistance simply did not possess. The comparison between French and foreign submachine guns became even more stark after the liberation. When Allied forces landed in Normandy in June 1944 and began the reconquest of France, they brought with them vast quantities of modern weapons. American forces alone carried tens of thousands of Thompson and M3 submachine guns. Free French forces, equipped and trained by the Americans, carried American weapons including Thompsons. British and Canadian forces brought Stens and Thompsons. As France was liberated, these weapons flowed into French hands. The reformed French army, reconstituted after liberation, faced the question of what submachine gun to adopt. The MAS-38 was available. The Germans had continued production at Saint-Étienne during the occupation, manufacturing several thousand more examples primarily for their own use. The factory and tooling were intact. France could resume MAS-38 production immediately. But French military planners, having observed 4 years of modern warfare, recognized that the MAS-38 was obsolete before it even entered service. The 7.6 FFS 20 Marcentum long cartridge was a dead end. No other nation used it. It could not share logistics with Allied forces. Most importantly, it lacked the power necessary for modern combat. Instead, France adopted a hybrid approach. In the immediate post-war years, French forces used American-supplied weapons extensively, including Thompsons and M3 grease guns. But France also sought to develop indigenous weapons. This led to the MAT-49, a new French submachine gun introduced in 1949. The MAT-49 represented everything the MAS-38 should have been. It fired standard 9mm parabellum ammunition, ensuring compatibility with NATO forces and the ability to use captured enemy ammunition. It featured a folding magazine housing that made the weapon more compact for storage and transport. It was designed for rapid production using stamped and welded components. It was reliable, controllable, and effective. The MAS-39 would serve France well in the colonial wars of the 1950s and 1960s, seeing extensive action in Indochina and Algeria. It proved its worth in conditions ranging from tropical jungles to desert mountains. French paratroopers, Foreign Legion units, and colonial troops relied on it heavily. The weapon remained in French service until the 1980s, a testament to its solid design. The MAS-38, by contrast, was largely retired by the early 1950s. Some remained in police and guard service for a few more years, but it was never again considered a frontline weapon. The story of the MAS-38 serves as a case study in military procurement failure. Every decision made in its development, when examined individually, seemed logical. A unique cartridge offered theoretical advantages in controllability and logistics. Precision manufacturing ensured quality and reliability. Careful distribution to specialized units reflected doctrinal preferences. But the cumulative effect of these decisions was a weapon that arrived too late, in too few numbers, firing an inadequate cartridge, and distributed to units that barely saw combat. When measured against German, Soviet, British, and American submachine guns, the MAS-38 was simply inferior in every way that mattered in actual combat. The contrast between French and foreign submachine gun development reveals broader lessons about military innovation and preparedness. Germany's submachine gun program succeeded because it was integrated into tactical doctrine and produced in massive numbers. The MP-40 wasn't dramatically better than the MAS-38 in raw technical terms. What made it effective was that German soldiers had hundreds of thousands of them, understood how to use them, and integrated them into combined arms tactics. Soviet submachine gun development succeeded because it prioritized mass production over refinement. The PPSH-41 was crude, but millions of them provided overwhelming firepower. British development succeeded because it focused ruthlessly on what mattered most, getting weapons into soldiers' hands quickly and cheaply. The Sten was ugly and crude, but it worked well enough and appeared in vast quantities. France's failure with the MAS-38 reflected larger failures in French military thinking during the interwar period. France prepared to fight the last war, emphasizing static defense and methodical operations. France prioritized precision and quality over quantity and speed of production. France developed weapons in isolation, creating unique cartridges and designs incompatible with allies and unable to exploit captured enemy resources. These tendencies, visible in the MAS-38 program, permeated French military procurement and planning. They contributed to the catastrophic defeat of 1940. The technical specifications tell part of the story. The MAS-38 measured 630 mm long with the stock extended, 460 mm with it folded. It weighed 2.87 kilograms empty. Its 32-round magazine held fewer rounds than the PPSH-41's 71-round drum, but was comparable to the MP-40's 32-round magazine and larger than the Thompson's 20-round stick. Its cyclic rate of fire, around 600 rounds per minute, was moderate and controllable. The offset barrel did reduce muzzle climb. The folding stock was compact and functional. From a pure engineering standpoint, the MAS-38 was well designed. But good engineering without adequate numbers, proper ammunition, and integrated doctrine meant nothing in combat. The few French soldiers who used the MAS-38 in combat in May and June 1940 found it controllable and reliable but lacking in stopping power. Resistance fighters who used it between 1940 and 1944 appreciated its compact size but struggled with ammunition scarcity. German occupation forces who employed captured MAS-38s found them adequate for guard duty but inferior to their own weapons for serious combat. Every assessment reached the same conclusion. The weapon worked, but was compromised by its weak cartridge. Had France developed the MAS-38 in 1935 as planned, produced it in large numbers throughout the late 1930s, and issued it widely to frontline troops, it might have made a difference in 1940. Not a decisive difference. No small arm could have overcome the fundamental problems with French military doctrine, leadership, and strategic planning that led to defeat. But more automatic weapons in French hands might have inflicted heavier casualties in close-quarters fighting. They might have made German breakthrough operations more costly. They might have provided French infantry with psychological reassurance that they possessed firepower comparable to their enemies. Instead, the MAS-38 arrived too late, in trivial numbers, and made essentially no impact on the course of the war. The post-war assessment of the MAS-38 by French military historians has been uniformly negative. It is remembered as a symbol of French unpreparedness in 1940, a weapon that epitomized good intentions undermined by poor execution. Modern collectors and firearms enthusiasts regard it as an interesting curiosity, a might-have-been weapon with unusual features and limited historical impact. Original MAS-38s in good condition are quite rare, most having been worn out in service or lost over the decades. The few that survive in museums and private collections serve as reminders of a turbulent period in French military history. The ammunition problem deserves particular emphasis because it illustrates a broader issue in weapons development. The 7.65 Epeng 20mm long existed only for the MAS-38 and the Model 1930 Fers pistol, a French military sidearm produced in small numbers. No other nation adopted it. When France needed to supply ammunition for these weapons, they could not source it internationally or capture it from enemies. Every round had to be manufactured domestically. During the occupation, this ammunition production was controlled by the Germans. After liberation, France had to restart production facilities specifically for this obsolete cartridge. By the late 1950s, French military ammunition plants had ceased producing 7.65 20mm long entirely. The cartridge, once envisioned as the future of French automatic weapons, had become a dead end, produced for only about 20 years and never exported successfully. Contrast this with 9mm Parabellum, developed by Germany in 1902. This cartridge became the standard pistol and submachine gun round for dozens of nations. It was produced in enormous quantities by multiple countries. It could be scavenged from enemy weapons, purchased internationally, or manufactured domestically using widely available specifications. A weapon chambered in 9mm Parabellum could be used anywhere in the world with confidence that ammunition could be found. France's decision to develop a unique cartridge seemed wise in peacetime when domestic production was assured. In wartime, when supply lines were disrupted and resources were scarce, it was a crippling disadvantage. The industrial aspects of submachine gun production reveal another dimension of the story. In 1940, Saint-Étienne could produce about 200 MAS-38s per week, using skilled workers and traditional machining methods. By comparison, British factories producing Stin guns reached production rates of over 10,000 per week by 1942. Soviet factories producing PPSH-41s achieved even higher rates. German factories, despite Allied bombing, continued producing MP-40s at rates of several thousand per week throughout the war. American factories produced tens of thousands of Thompsons and M3s weekly. The differential in production capacity between France and other major combatants was staggering. Even if the MAS-38 had been the finest submachine gun ever designed, France lacked the industrial capacity to produce it in war-winning numbers. This production differential reflected broader economic realities. Germany had mobilized its economy for war throughout the 1930s. Soviet industrialization under Stalin, however brutal, had created vast manufacturing capacity. Britain's industrial base, while smaller than Germany's, was protected by geography and supported by empire resources. America's industrial capacity dwarfed all other nations combined. France, despite being a major European power, had not matched its rivals in industrial mobilization. French factories in 1940 still operated largely on peacetime schedules with peacetime methods. The shock of defeat and occupation prevented France from ramping up production as Britain had after Dunkirk. The tactical employment of submachine guns offers another angle for comparison. German doctrine in 1940 emphasized combined arms coordination and rapid maneuver. Submachine guns fit naturally into this approach, providing mobile infantry with firepower for close assault and exploitation. Soviet doctrine emphasized mass and overwhelming force. Submachine guns enabled Soviet infantry to close with enemies quickly and overwhelm them with automatic fire. British and American doctrine, while different in details, both recognized the value of automatic weapons for aggressive infantry operations. French doctrine in 1940 emphasized prepared positions, deliberate advances, and fire superiority through crew-served weapons. Submachine guns had no clear place in this doctrine, which helps explain why they were not prioritised or widely distributed. After 1945, when France rebuilt its military, submachine gun doctrine changed dramatically. French experience in Indochina and Algeria, fighting counterinsurgency campaigns in close terrain against elusive enemies, demonstrated the value of automatic weapons for every infantryman. The MAS-39, distributed widely to French forces, reflected this doctrinal shift. But in 1940, French military thinking had not evolved to embrace these weapons, and the MAS-38 suffered accordingly. In the final analysis, the MAS-38 represents a historical footnote, a weapon that might have mattered if circumstances had been different, but ultimately had negligible impact. It was neither the best nor worst submachine gun of World War II. It was simply irrelevant. Produced too late in too few numbers, firing an inadequate cartridge, and issued to the wrong units, it failed to influence events. When historians discuss the weapons of World War II, the MAS-38 merits a brief mention, a curiosity noted primarily for its unusual design and limited service. The weapons that mattered, the guns that shaped battles and campaigns, were the MP-40, the PPSH-41, the Sten, and the Thompson. These were the submachine guns that armed millions of soldiers, that appeared in countless photographs and combat reports, that veterans remembered decades later. The MAS-38, by contrast, is largely forgotten, a symbol of French military failure in 1940 and a reminder that good intentions and careful engineering mean nothing without numbers, proper ammunition, and integrated doctrine. The French had designed a submachine gun. Their enemies had designed war-winning weapons and produced them by the millions. That difference, replicated across every category of military equipment and planning, explains why France fell in 6 weeks, while its enemies fought for 6 years. The story of French submachine gun development extends beyond the MAS-38 itself into the broader context of French small arms philosophy and the industrial base that supported it. To understand why France produced only 2,000 submachine guns when Germany produced 250,000 requires examining the decades of decisions and assumptions that led to 1940. French military thinking after World War I was dominated by the experience of that conflict. The Great War had been won, from the French perspective, through defensive firepower and industrial attrition. The machine gun, the artillery piece, and the fortification had proven decisive. Individual infantry weapons mattered less than crew-served weapons and prepared positions. This thinking shaped French procurement priorities throughout the 1920s and 1930s. Money went to the Maginot Line, to artillery, to tanks designed for infantry support. Small arms received relatively little attention or funding. The attitude was that rifles had been good enough in 1918 and would be good enough in the next war. This mindset extended to automatic weapons. The French had observed German stormtrooper tactics in 1918, which relied heavily on the MP-18 submachine gun for close assault. French military analysts studied these tactics but concluded that they represented desperation measures by a losing army, not innovations worth emulating. France had won the war using methodical tactics and superior firepower. Why abandon proven methods for experimental weapons? The submachine gun, in French military thinking of the 1920s, was a specialty tool for trench raids and limited operations, not a general issue weapon. This assessment would prove catastrophically wrong, but it dominated French procurement for 2 decades. When France finally decided to develop a submachine gun in the early 1930s, the project reflected typically French priorities. The weapon would be indigenously designed using French engineering principles. It would fire a French cartridge manufactured to French specifications. It would be produced in French arsenals by French workers. There would be no licensed production of foreign designs, no adoption of foreign cartridges, no compromise with French standards. This insistence on indigenous development, while understandable from a nationalist and industrial independence perspective, meant that France could not benefit from the experience of other nations, or rapidly scale up production using proven designs. The Saint-Étienne arsenal, tasked with MAS-38 production, exemplified French military manufacturing. Established in 1764, the facility had centuries of tradition in precision arms making. Its workers were highly skilled craftsmen who took pride in their work. The arsenal produced weapons to exacting tolerances using traditional machining methods. Each weapon was essentially handcrafted, with components fitted individually. This approach produced excellent quality but terrible production speed. Saint-Étienne could not simply hire unskilled workers and train them quickly. The manufacturing methods required years of experience. When war came and production needed to increase rapidly, the arsenal could not scale up effectively. Compare this to Soviet arms production. Soviet factories in the 1930s were designed from the start for mass production by minimally trained workers. When war came, Soviet industry could relocate factories east of the Urals, hire peasants with no manufacturing experience, and train them to produce weapons in weeks. The PPSH-41 was specifically designed to be produced by people who had never seen a submachine gun before. Components were simple, tolerances were loose, assembly required minimal skill. A Soviet factory could go from zero production to thousands of weapons per week within months. Saint-Étienne, bound by traditional methods and exacting standards, could not achieve such scaling. The cartridge development process revealed similar problems. French ordnance engineers approached the 7.6-inch twin-year-long project with scientific rigour. They conducted ballistic tests, analysed wound ballistics, studied recoil characteristics, and developed detailed specifications. The entire process took years and involved multiple committees and review boards. By the time the cartridge was finalised in 1935, other nations had moved on. Germany had already settled on 9mm parabellum for submachine guns. The Soviet Union was using 7.62 25mm Tokarev. Even the United States, which would not enter the war for years, had standardized on 45 ACP for submachine guns. France's careful, deliberate development process produced a cartridge that was obsolete before it entered production. The small scale of initial production reflected budget priorities. The French military budget in the late 1930s allocated relatively little to small arms. Most money went to the Maginot Line fortifications, which consumed enormous resources. Additional funds went to tanks and artillery. The Air Force demanded modern aircraft. The Navy needed ships. By the time these priorities were satisfied, little remained for rifles and submachine guns. The MAS-38 program received enough funding to tool up Saint-Étienne and begin production, but not enough to expand capacity or accelerate the timeline. French politicians and military leaders genuinely believed the Maginot Line and their large army would deter Germany. Small arms seemed less urgent than fortifications and heavy weapons. The distribution of completed MAS-38s to the Garde Mobile rather than army infantry reflected doctrinal confusion about the weapon's role. The Garde Mobile was essentially a militarized police force responsible for maintaining order in French territory. Giving them submachine guns made sense for their mission, which might involve dealing with riots or civil disturbances at close range. But this decision meant that when war came, the weapons were in the hands of troops unlikely to face German armour and infantry. The army units that did face German assault had virtually no submachine guns. This distribution pattern suggests that French planners never really understood what submachine guns were for or how they should be employed in modern warfare. German planning, by contrast, had integrated submachine guns into tactical doctrine from the start. German infantry manuals from the late 1930s specified how many submachine guns each type of unit should have and how they should be employed. Squad leaders, assault pioneers, paratroopers, and vehicle crews all had clear allocation priorities. German training emphasized coordinated assault using a mix of bolt-action rifles, submachine guns, and machine guns. Each weapon had a defined role. The submachine gun's role was to provide mobile automatic fire during assault and exploitation phases. This clarity of purpose ensured that German industry knew what to produce, and German units knew how to employ the weapons once they arrived. The French lacked this clarity. Even within the military, different factions disagreed about submachine guns. Some officers viewed them as valuable innovations, others dismissed them as wasteful of ammunition and unsuited to French tactical methods. Without consensus, procurement remained limited and distribution haphazard. The result was that when war came, France had neither enough submachine guns nor a clear doctrine for using them. German forces, with both adequate numbers and clear doctrine, overwhelmed French positions that might have held if defenders had possessed more automatic weapons. The comparison with other French weapons programs reveals that the MAS-38's problems were not unique. The French tank program, for example, produced excellent individual designs like the Saumur S-35 and Char B-1 tanks that were in many ways superior to German panzers. But French tanks suffered from poor radio communications, doctrine that dispersed them in infantry support roles, and production numbers far below German levels. French artillery was generally excellent but suffered from insufficient motorization and outdated fire control methods. French aircraft designs were often competitive with German types, but were produced in inadequate numbers and suffered from spare parts shortages. Across every category of military equipment, France demonstrated the same pattern: good individual designs undermined by insufficient production, doctrinal confusion, and inadequate logistics. This pattern reflected deeper problems in French military culture and civil-military relations. The French military establishment was intensely conservative, dominated by officers whose formative experiences were in World War I. Innovation was viewed with suspicion. Young officers who advocated new tactics, like Charles de Gaulle, with his proposals for mechanized warfare, were marginalized. The High Command remained convinced that the next war would resemble the last one, only longer and more attritional. This mindset pervaded everything from strategic planning to weapons procurement. The submachine gun, representing a new approach to infantry combat, found few champions in a military culture that valued tradition and proven methods over experimentation and innovation. French industry, while sophisticated and capable, was not organized for wartime mass production. Most French arms manufacturers were small to medium-sized companies using skilled labor and traditional methods. The concept of assembly line production with interchangeable parts was understood but not widely implemented. When Britain faced invasion after Dunkirk, British industry rapidly reorganized for war production, with automobile plants converting to weapons manufacture and thousands of new workers trained quickly. France in 1940 had not yet made this transition. French industry was still producing weapons the way it had in peacetime, with skilled craftsmen and slow, precise methods. By the time France fell, the industrial mobilization that might have produced adequate weapons in adequate numbers had barely begun. The German occupation of French arms plants revealed the extent of the gap. When German administrators took over Saint-Étienne and other arsenals, they were shocked at the slow production rates. German industrial engineers, experienced in mass production methods, immediately saw inefficiencies everywhere. German reports noted that French workers, while skilled, were working with outdated equipment and methods. The Germans attempted to increase production of the MAS-38 for their own use by introducing German manufacturing methods, but even with these changes, production never approached German levels for the MP40. The fundamental design of the MAS-38, requiring extensive machining, limited how much production could be accelerated. French resistance acquisition of weapons after 1940 illustrated another aspect of the small arms situation. The resistance needed weapons desperately but initially had access to very few. Some soldiers had hidden weapons after the armistice, but these caches were limited. The few MAS-38s in resistance hands represented a tiny fraction of what was needed. This shortage forced resistance groups to rely almost entirely on Allied airdrops. Between 1941 and 1944, Britain and later America dropped thousands of tons of weapons and supplies to French resistance groups. The overwhelming majority of these weapons were British or American designs, not French. The Steen gun became the iconic resistance weapon, not because it was particularly good, but because Britain could manufacture tens of thousands per week and drop them into France. The Sten's crude simplicity proved ideal for resistance use in ways the MAS-38 never could have been. A Sten could be maintained with minimal tools, repaired by anyone with basic mechanical knowledge, and its 9mm ammunition could be scavenged from German weapons. If a Sten was captured or lost, it could be quickly replaced with another from the next airdrop. The MAS-38, requiring more careful maintenance and firing unique ammunition, would have been a liability. Even if France had managed to produce thousands of MAS-38s and distribute them to resistance groups, the ammunition logistics would have been impossible. The unique cartridge meant resistance fighters would have been entirely dependent on captured French stockpiles, which were controlled by the Germans. Resistance fighters who did use the limited numbers of MAS-38s available generally viewed them as adequate but unexceptional. The weapon's compact size was appreciated for concealment, essential for underground operations. The low recoil made it easy to control, important for fighters who might not have extensive training. But the weak cartridge was a constant complaint. Resistance operations often involved ambushes at close range where stopping power was critical. A target hit with a Stinn or Thompson usually went down immediately. A target hit with a MAS-38 might keep fighting, potentially returning fire or raising an alarm. In the brutal calculus of resistance warfare, where failure often meant torture and execution, this difference mattered enormously. The post-liberation assessment of French small arms by American and British military advisors was brutally honest. Reports noted that French infantry weapons were generally adequate but outdated. The MAS-36 rifle was well made but no better than weapons other nations had fielded years earlier. The FM-24-29 light machine gun was effective but heavy and complex. The MAS-38 was dismissed as inadequate for modern warfare. American advisors recommended that France adopt American weapons standards and manufacturing methods. The French military, facing the reality of its obsolete arsenal, largely agreed. The reconstructed French army in 1944 and 1945 was equipped almost entirely with American weapons, including American submachine guns. This dependence on foreign weapons was humiliating for a nation that prided itself on military tradition and industrial capability. France had been a major arms exporter before the war. French weapons had equipped nations around the world. To become dependent on American and British arms was a stark demonstration of how far France had fallen. French military planners after liberation were determined to rebuild an indigenous arms industry, but they recognized that the old methods had failed. Future French weapons would need to be designed for mass production, use international standard calibers, and incorporate lessons learned from 4 years of modern warfare. The development of the MAT-39 submachine gun embodied these lessons. Work began in 1946, immediately after the war. The design team included veterans who had used various submachine guns in combat and understood what worked and what didn't. They studied German, British, American, and Soviet designs, taking the best features from each. The result was a weapon that could be mass-produced, fired standard ammunition, and incorporated modern features like a folding magazine well and simplified maintenance. The MAT-49 represented what the MAS-38 should have been if France had understood modern warfare requirements in the 1930s. The MAT-49 would serve France extensively in colonial conflicts. In Indochina, French paratroopers and Foreign Legion units relied on it heavily in jungle warfare against Viet Minh forces. The weapon proved reliable in harsh tropical conditions and provided adequate firepower for close-range engagements. In Algeria, French forces used MAT-49s extensively in counterinsurgency operations. The weapon's combination of portability and firepower made it ideal for the urban combat and mountain warfare that characterized the Algerian conflict. By the time the MAT-49 was retired in the 1980s, it had proven itself in decades of hard service, vindicating the design decisions made in its development. The contrast between the MAT-49's successful service and the MAS-38's negligible impact illustrates fundamental principles of weapons development. A weapon must be produced in adequate numbers to matter. It must fire ammunition that is readily available and effective. It must be reliable and maintainable under field conditions. It must fit into tactical doctrine and be employed by troops who understand its capabilities. The MAS-38 failed on most of these criteria. The MAT-49 succeeded on all of them. The difference was that the MAT-49 was developed by a nation that had learned painful lessons about modern warfare, while the MAS-38 was developed by a nation still preparing to fight the previous war. The ammunition question deserves further exploration because it reveals so much about interwar French military thinking. The decision to develop the 7.65 20mm long cartridge was not irrational. French engineers had legitimate concerns about the 9mm Parabellum's recoil characteristics and wanted something more controllable. They also wanted a cartridge that could be used in both submachine guns and pistols, simplifying logistics. These goals were reasonable. The execution was the problem. By developing a unique cartridge, France locked itself into domestic production with no possibility of international sourcing or battlefield scavenging. The cartridge's low power meant that even if logistics could be solved, the weapon firing it would be less effective than competitors. Contrast this with the American decision to use .45 ACP in submachine guns. The cartridge already existed for pistols. It was manufactured in enormous quantities. Its stopping power was proven. American submachine gun designers didn't try to develop a better cartridge. They used what was already available and designed weapons around it. This pragmatic approach meant the Thompson could share ammunition with the M1911 pistol, simplifying logistics. It meant American industry didn't need to tool up for a new cartridge. It meant ammunition was never a limiting factor in Thompson deployment. France's pursuit of the theoretically optimal cartridge over the practically adequate one exemplified a tendency toward perfectionism that hampered weapons development throughout the interwar period. The manufacturing methods employed at Saint-Étienne also reflected priorities that made sense in peacetime but failed in war. French military arsenals were state-owned facilities employing civil servants with job security and guaranteed pensions. Workers were skilled and took pride in craftsmanship. Production standards were exacting. Quality control was rigorous. This system produced excellent weapons in peacetime when time and cost were less critical. But it could not rapidly scale up when war came. Hiring new workers meant navigating civil service bureaucracy. Training them took months or years. Expanding facilities required government appropriations and lengthy construction projects. By the time France could have scaled up production significantly, the war was lost. German and Soviet systems, while different from each other, both proved more adaptable to wartime needs. German arms production relied on a mix of state arsenals and private contractors, allowing rapid expansion by contracting with additional companies. Soviet production relied on state factories designed from the start for mass production with unskilled labour. Both systems could increase output quickly when needed. French reliance on traditional state arsenals employing skilled craftsmen was optimal for peacetime but catastrophically inadequate for war. This realization after 1945 led to significant reforms in French military procurement, with greater involvement of private industry and emphasis on design suited to rapid mass production. The human dimension of the MAS-38's failure is worth considering. The engineers who designed it were talented professionals doing their best with the specifications and resources they had. The workers who manufactured it were skilled craftsmen producing quality weapons. The soldiers who received it were brave men facing impossible odds. None of these individuals failed. The system failed. French military and political leadership failed to understand what modern warfare required. French industrial policy failed to create manufacturing capacity suitable for wartime production. French military doctrine failed to integrate new weapons and tactics. The MAS-38's irrelevance was a symptom of these larger failures, not a cause. Veterans of the 1940 campaign who used MAS-38s in the limited combat they saw generally remembered the weapon without strong feelings either positive or negative. It worked adequately in the few engagements where it was employed. It didn't jam or malfunction notably. It simply lacked the power and impact of enemy weapons. One veteran, interviewed decades later, described firing a MAS-38 at German motorcycle troops during a roadside ambush. He remembered hitting several Germans, seeing them flinch and stumble, but watching them continue to function and return fire. Meanwhile, German MP-38 fire cut down French soldiers with brutal efficiency. The veteran survived by retreating when his ammunition ran out. He remembered thinking that French bullets seemed to wound while German bullets seemed to kill. That perception, whether entirely accurate or not, captured the reality of fighting with an underpowered weapon against enemies equipped with more effective arms. The statistical record of the MAS-38's combat use is nearly non-existent. So few were used in combat that reliable data on their effectiveness was never compiled. German after-action reports from 1940 rarely mention encountering French submachine guns, suggesting that engagements involving them were rare enough to be unremarkable. French after-action reports from units equipped with MAS-38s generally don't provide detailed weapon performance data, focusing instead on the overwhelming nature of German attacks and the rapid collapse of defensive positions. The few references that do exist suggest the weapon functioned as designed, but had no significant impact on combat outcomes. In the final analysis, the MAS-38's combat record is one of absence rather than presence, a weapon that barely mattered because it barely appeared.